Okay, we have here the integral from 0 to infinity sine x cubed over x dx. Now for this one, you will notice this has a real similarity to the Lobachevsky's integral formula. It's just the only difference is we have x cubed. If this was just sine x over x, then the answer to this would be pi over 2. And it's interesting because sine x to the cube by itself I think is impossible, or I don't think we can get a nice solution if we didn't have the x. But I think what we can do is let's just make a u substitution and try to clean up this x cubed and see if we can get it into something where we can use Lobachevsky's integral formula or something nice. So I'll go ahead, take a derivative, get the dx value, and it's going to be 3x squared dx. And of course, I don't really have the 3x squared anywhere, so let's rearrange it, kind of isolating the dx. So I can write it as du over 3x squared. And so we'll go ahead and substitute. First, if I plug in infinity, that's still going to infinity. If I plug in 0, lower bound's going to 0. Now for the numerator, this becomes sine of u. And actually, normally what I would like to do is like isolate x and substitute here. What I'm going to do instead is let's just kind of keep the x for the moment because it's going to clean up nicer. So technically you don't want both variables in the integral, so you can't really integrate that, but we can do it temporarily until we clean it up. And then for their dx value, we'll do du. And again, we'll have this 3x squared here that we need to clean up. And then from here, we can take 3 out front in the denominator and write it as 1/3, going from 0 to infinity. Now, if I multiply x times x squared, this is going to be x cubed. And we know that that's u. So putting that together, what we're left with is sine u over u du. But now we've got it reduced to the thing I mentioned in the beginning, just sine u over u, or the same thing as like sine x over x, and we can use our Lobachevsky's integral formula. What we can do for the f of x part here is just kind of create something like a 1 right here. So the f of u value is going to be just equal to 1. This formula allows us to reduce it to just the function f of x from 0 to pi over 2. We'll change our bounds. We have this condition on it that we need our function to be pi periodic. The only thing is with 1, none of this really matters. There's no inputting an x into 1, it's just 1. So this is always going to work here. And so we can go ahead and use our formula. So what we're going to get is 1/3, reducing the bounds to 0 to pi over 2. Again, the function on this is just 1, so we're just integrating 1. Go ahead, integrate. Integral this is going to be u, evaluated from 0 to pi over 2. 0 is nothing, plug in pi over 2. And so for the final solution of this, we just get pi over 6. Okay, there you go. Thanks everyone for watching. Have a good day.